Day 15 of 90, and today we're fixing a bug that hides until production. Picture an API client built as a plain object. It has a base URL, some headers, and auth token. Looks clean. Then 6 months later a teammate writes client.token equals undefined somewhere in a retry handler, and now every request 400 once silently. No compile error. No test failure. Just angry users. TypeScript classes exist to make that line of code refuse to compile. Let's seal it. Here's the leaky version. Const client equals base URL https://api.app.com token secret request count 0. Every field is public and writable. Any caller anywhere can reach in and corrupt state. The fix is a class, and the first tool is access modifiers. Private base URL, private token. Now those fields are invisible outside the class. The compiler enforces it. Write client.token from a route handler and you get property token is private. That's not a lint warning you can ignore. That's the build breaking before you ship. Next, read only. Some state should be set once and never change. Request count we mutate internally, fine. But the base URL? That's configured at construction and frozen forever. Private read-only base URL, string. Now even inside the class, an accidental reassignment fails to compile. Read-only and private compose, private controls who can see it, read-only controls who can change it. Together they encode an invariant directly into the type. This value is internal and permanent, so the rule lives in the shape of the class, not in a comment everyone ignores. Now the boilerplate problem. Constructors usually look like, you declare a field, then write this.base URL equals base URL, this.token equals token, line after line. TypeScript kills that with parameter properties. Constructor, private read-only base URL, string, private token, string. Putting the modifier in the constructor's signature declares the field and assigns it in one move. No separate declaration, no this.x equals x, same type safety, a third of the code. This is the idiom you'll see in every well-written TypeScript service, and once you use it you won't go back. Now make it actually useful with generics. Our fetch method shouldn't return any that forces callers to cast, and casts are where type safety goes to die. Instead, public async fetch t, path, string promise t. The caller writes client.fetchUser/me, and the return type flows straight through. No assertion, no as user. The compiler tracks it end to end. And the request building logic? Market protected build request. Protected means subclasses can use it, but external code can't. It's an internal helper that's still shareable down the inheritance chain. Private, protected, public, 3 levels, each a deliberate contract. Here's where classes really earn their place: testability through abstraction. Define an abstract base abstract class HTTP client with abstract fetch t, path, string promise t. Abstract means no implementation here, but every subclass must provide one, and the compiler checks. Now you write a real HTTP client that hits the network and a mock HTTP client that returns canned data. Both extend HTTP client. Your express route declares it needs an HTTP client, the base type, and accepts either one. Swapping the real client for the mock-in tests requires zero type gymnastics, zero assertions. The abstract class is the contract, enforced. Watch the compiler catch a real bug. In our express route, apt-get/profile async raq res equals const user equals await client.fetchUser/me res.json user.email. Typo email instead of email. With a plain object returning any that ships, and users get undefined in production. With our generic class, fetchUser means the compiler knows the shape, and user.email is a hard error. Property email does not exist on typeuser. The silent 401's cousin, the silent undefined, caught at build time. So, private and read-only to lock state, parameter properties to cut boilerplate, generics so types flow without casts, and abstract bases so your code is testable by construction. A class isn't a heavier Object, it's an object with its rules compiled in. Reach for one the moment you have an invariant worth protecting. Day 15 done. The takeaway: classes turn runtime bugs into compile errors before the code ever ships. Subscribe for day 16.